The reference counting subsystem maintains an atomic counter for each allocated memory page within the virtualized address space. Each page entry contains a reference count field of type uint32, initialized to 0 upon allocation. When a process or internal component acquires a reference to the page, the counter increments. Upon release, it decrements. The page becomes eligible for eviction only when the counter reaches 0 and no pending I/O operations reference the page. Reference acquisition follows a two-phase protocol. The requesting thread first consults the page directory to locate the page descriptor. It then attempts an atomic compare and swap operation on the reference count. If the count equals or exceeds the eviction threshold, acquisition fails and returns a retry signal. Otherwise, the increment succeeds and the thread proceeds with page access. This mechanism prevents use after free conditions in concurrent scenarios. Reference release operations decrement the count using atomic operations identical in structure to acquisition. A release that reduces the count to 0 triggers evaluation of a page's eviction eligibility. The system checks whether the page has been marked for deferred eviction due to I/O in flight. If deferred status is not present, the page transitions immediately into the eviction candidate queue. Release operations never block and complete in constant time. The deferred eviction flag provides synchronization for pages involved in a synchronous I/O. When an I/O operation begins, the flag is set regardless of current reference count. Readers and writers hold a reference for the operation's duration. Upon I/O completion, the flag clears. If the reference count simultaneously reaches 0, the completion handler enqueues the page for eviction. This prevents premature reclamation of pages with pending disk transfers. Overflow conditions occur when reference count increments exceed the uint32 maximum value. Such overflow triggers a system event log entry and halts acquisition for the affected page. The system administrator must drain references or restart the subsystem. Overflow prevention strategies include periodic analysis of pages with sustained high reference counts and automatic migration to dedicated memory pools with separate counting infrastructure. Contention on heavily referenced pages is mitigated through lock-free atomic operations and hardware-assisted CAS instructions. For pages exceeding a configurable hotness threshold, the system may allocate a secondary reference counter with a read-write spin lock. This distributed counting approach reduces cache coherency traffic on the primary counter. Periodic consolidation operations merge secondary counters back into the primary count when traffic decreases. The reference count snapshot mechanism captures the current count value without blocking ongoing acquisition and release operations. Snapshots employ a three-value technique: reading the counter, noting a generation epoch, reading again, and verifying the epoch unchanged. If the epoch differs, the snapshot is invalid and must retry. This approach provides eventually consistent visibility into reference counts for monitoring and diagnostic purposes. Leak detection identifies pages whose reference counts remain non-zero beyond configurable timeout intervals. The monitoring daemon periodically scans pages with elevated counts and long tenure. Pages exceeding the leak threshold are reported to the system log with stack traces of threads holding references. Administrative tools provide forced reference release mechanisms for pages declared as leaked, though this operation requires explicit confirmation. Reference invalidation occurs when a page is deallocated while references remain outstanding. The system marks the page with an invalidation sentinel value instead of decrementing the live counter. Subsequent release operations detect the sentinel, increment a separate invalidation counter, and cease normal processing. Once all invalidation references resolve, the page metadata is purged. This mechanism prevents corruption from use after free access patterns. The reference count history buffer maintains a rolling circular log of reference count state transitions for each page. Every time the count crosses a boundary value, an event is recorded with timestamp and thread identifier. The buffer stores the last 2,000 transitions per page. Diagnostic tools examine this history to identify reference patterns, detect anomalies, and trace the source of unexpected count increments or decrements. Grace period handling ensures that references held by transient threads do not unduly delay page eviction. When a page enters the candidate queue, it begins a grace period measured in milliseconds. During this window, new reference acquisitions are rejected. If the reference count reaches 0 before the grace period expires, the page is immediately evicted. Otherwise, the page cycles back to the candidate queue after cleanup operations. Cross-NUMA domain references incur additional overhead due to remote memory access costs. The subsystem tracks whether each reference originates from the same NUMA node as the page. Pages with many cross-domain references are flagged for potential migration to a memory pool on a more central node. Migration decisions balance the cost of data movement against expected latency improvements and are made by an offline analysis phase. Reference count decay applies to pages not actively referenced for extended periods. After a configurable inactivity interval, the system begins a slow decay process where the count is periodically reduced by a fixed percentage. Decay is logged and may be reversed if a new reference is acquired. This mechanism prevents long-lived pages from permanently occupying memory due to stale references held by crashed or deadlocked processes. Checkpointing of reference count state persists a snapshot of all page counts to stable storage at configurable intervals. The checkpoint includes the page identifier, current reference count, deferred I/O flag, invalidation status, and last access timestamp. During recovery from a system restart, reference counts are restored from the most recent checkpoint. Pages whose I/O flag remains set at recovery are assumed to have failed operations and are marked for reconstruction. Metering and throttling prevent the reference counting subsystem from becoming a bottleneck under high concurrency. The system implements per-core statistics tracking acquisition and release rates. If acquisition rate exceeds a threshold for sustained periods, new acquisitions are paused briefly and threads are asked to batch their requests. Throttling signals propagate through a lock-free message queue to avoid additional contention. Configuration parameters for the reference counting subsystem include overflow thresholds, grace period duration, decay intervals, and hotness detection cutoffs. Each parameter has a documented default value alongside acceptable ranges. Changes to configuration take effect immediately for newly allocated pages. Existing pages retain their configuration epoch and are updated only upon explicit administrative commands or during scheduled maintenance windows.